One of the most useful features of SSH is it can be used to set up a local SOCKS proxy tunneling with dynamic ports. This means you can set up a local SOCKS 5 proxy on your device that creates an encrypted tunnel to the SSH server. A dynamic port allows you to use any protocol and get to any site, as long as obviously the server allows that. And you would use the following type of command to create this SOCKS 5 proxy. And in this example, it is creating a 8080 port on the local system. So let's talk through the command just so you can understand it. The -F tells SSH to go into the background just before it executes the command. And actually you can use this same switch with the local and remote tunneling. If you don't want to actually log in and have the login screen up, you can send it to the background and then you have to kill it later. The capital N instructs SSH to not execute a command on the remote machine, and N redirects standard in from dev null, actually prevents reading from standard in. This must be used when SSH is running in the background. If you remove these, then it won't run in the background. You can just run it with -D and it will still work, but you'll get the login prompt and you'll log into the actual SSH box and you'll be given your shell prompt. And the -D, to explain it, that's what specifies the local dynamic application level port forwarding. This works by allocating a socket to listen to a port on the local device. Whenever a connection is made to this port, the connection is forwarded over the secure channel and the application protocol is then used to determine where to connect from the remote machine. Currently, the SOCKS 4 and SOCKS 5 protocols are supported and SSH will act as a SOCKS proxy server. Only root can forward privileged ports. So I'm going to run the command not in the background first, just to demonstrate with the -D. And that will give us the login prompt, but it has created the SSH tunnel. And if I exit that, it drops the tunnel. But let's run it with this and run it in the background with the -F, capital N, N. And that puts it in the background. And we can see it there. And we can see it listening here, IPv4 and IPv6. So let's use this SOCKS proxy that we've created with SSH. So if we go here, Preferences, Advanced, Network, Settings, and then we need to add the port, whichever port that we decided to add for the local host. We need to add this that's been added in here, local host, and then we need to add the port 8080. And then let's do a search to see if it's actually working. There we go, 52.16. And if we look here, we can see it's at the Amazon Dublin data center. So yeah, it's working perfectly fine. If you want to use an application that doesn't have a proxy setting, then you can use tsocks in Linux. And this command here will download it for you. This is Kali as well, Debian. Then we need to edit the tsocks config file, which is here, etc tsocks.conf. Go down here. And we need to find the default server, and we need to change that to 127.0.0.1, or where we've set up the SSH dynamic port proxy. And of course, we need to put in the correct port, whichever port we have chosen to use. Save that. So then it's a case of just typing tsocks and then whatever command it is that you want to use. So maybe nmap. Or let's check out if we have the correct IP address, if it is actually working. So here we're going to do a wget to IP info, and then I'm going to pull down the correct variable for my IP address. And there we go, 52.16. So wget has gone through TSOCKS, which has forced it down the SSH proxy. Let's just confirm. Yeah, it's the same IP address. And with TSOCKS, we can launch most applications and command line tools. But I don't know if I would 100% rely on it if the consequences are high. You never know when it might just fail. And what happens if it dies? There's no kill switch. So you need to bear those things in mind. And TSOCKS is just one example of how you may be able to force applications to use proxies, and we discussed this in the section on Tor. So here are other proxifiers. TSOCKS is a proxifier, and ProxyChains, for example, will do the same as TSOCKS and is available in Kali. And in Windows as well, I'll demonstrate setting up a SOCKS proxy using SSH. So here we are in PuTTY. We obviously need the correct IP address, the correct port. It needs to be SSH. Then we need to go down to connection, SSH, tunnels. It's the same again as we keep going through. We need to change this to dynamic and then put in the local port that we are wanting to open up. So 8080 is our port of choice. That's good. Session, correct IP, correct port, open. Let's log in. So there we are, our proxy should now be set up. So let's test, see if it is working. So let's use the browser to do that. Options, advanced, network, settings, manual proxy configuration, set up the SOCKS proxy, SOCKS 5, exactly what we've already done. Local host, 8080, okay. And there we are, 52.16. Same IP address again. And there we are going through the Amazon data center in Dublin. Let's pop back to Debian. Note, if you are using SSH as a SOCKS 5 proxy for tunneling traffic, be aware that we mentioned this before, that it's possible that SSH tunnels are susceptible to web traffic fingerprinting, which I have mentioned already when talking about OpenVPNs and Tor. And if you remember, it is a passive eavesdropping attack that looks at the size and time of the encrypted data stream, where although the adversary only watches encrypted SSH traffic, they can still guess what web page is being visited. Because all web pages have a specific traffic pattern, they can only guess the website if they have that pattern already. So if they don't have that pattern, then they cannot guess what web page it is that you're visiting. The content of the transmission with SSH is still encrypted, so it's still hidden, but to which website that you're connecting to or the page won't be secret anymore if they have the pattern and they're able to detect it. And there are multiple research papers on it that I've pointed you to at it before. And several researchers have developed web page fingerprinting attacks on encrypted web traffic as occurs when the victim uses encrypted tunnels such as SSH. And according to a report, they yielded greater than 90% accuracy for identifying HTTP packets on conventional VPNs. However, some protocols like OpenSSH and OpenVP required a larger amount of data before HTTP packets were identified. You obviously would need an adversary that was somehow able to scoop up your traffic if they were in the middle, if they own the network, for example. So just bear in mind, web traffic fingerprinting does make it possible in certain cases with certain adversaries that they can tell what page you visit if they know what possible pages it might be in advance. If you've run your SSH proxy in the background, let's just run this, we can see it here, then you also are going to want to stop that proxy at some time. You can kill the process using pkill and then the name of the process, SSH, or you can use kill and the ID number of the SSH process. And there it's gone. And one final thing just to show you is that you can issue remote commands without having to actually create a shell. And you do that with this -- and then the command. So let's do who am I. There we go, root. There we can see it's done the curl command and return back its IP address.